Hello everybody, welcome to Science, Technology and History Explained. Today we are looking at some fun science. Why can't we see any green stars? Why are all the stars we can see white, yellow, red or blue? So why don't we have any green stars? So let's get started. So if we look at typical images, for example, this is the Cat Paw Nebula. You can see clearly some stars are bright blue. Most of them are maybe reddish yellow or white. And if we look at the categorization of stars, typically they go from very hot stars are typically blue, then they become white yellow, and then they end up with red, for example, red dwarfs or red super giants, so that we can see some of the stars. If we zoom in with a telescope, we can see the reddish faint, but there is no green in this sequence. So why is that? So first, to understand this, we need to understand what is actually color and visible light. So starting off with light, the visible light. Normally, if we look at the whole electromagnetic spectrum, there is a lot of electromagnetic rays that we cannot see, like gamma rays, X-rays, ultraviolet light, infrared, microwave, and long radio waves. Our eyes, we don't have any sensors to detect any of that. Our eyes are tuned in a very small band. If you look at the whole spectrum, where short wavelength is blue and longer wavelength is red, and we have all the colors in between of the rainbow. And then we need to distinguish between color of light is not the same thing when we say a color of an object that reflects light. So for example, an item that emits light, like it could be a star or lamp or flames or a laser or something like that, either it provides a continuous spectrum of light, and this is typically if the element is hot and dense. A source, like typically a star, it would send multiple wavelengths across the electromagnetic wave. But if it is something not dense, like a gas in a flame or a laser pointer, then we are sending some few wavelengths. For example, a lamp, a sodium lamp that is typically orange, it's only sending out some wavelengths around this orange band. If you have different metals in a gas, for example, strontium gives us a nice red light, copper is giving something blue, green, etc. But stars will not be emitting only one wavelength, they will be emitting in a long range because they are hot and dense. If we for a moment look at why different objects that reflect light, they have different colors. Basically all objects that don't produce light are reflecting light. So for example, if we look at the green leaf, this means that the white light that is coming in typically has a white light, has basically all the components of all the colors in this spectrum, and the leaf absorbs, for example, red and blue and yellow, but then the green is not absorbed so much, so the green light is reflected and our eyes register the green light. If it's a blue ball, for example, then or something like that, a blue object, then it absorbs the red and reflects the blue, and what we reflected we see as color, but it's not the same thing as a lamp. This is what it's emitted we can see as color. And if we look at the light emission of stars and gas and something like this, so if we have like a star that's hot and dense, it gives us emission of light and brightness on various scale of the continuous spectrum. If we have something like a gas or the flame I showed you in the previous page, it will be sending out some lights characteristic for the composition in different bands. And then how do our eyes really interpret color? So normally the light comes into our eye, either it's the produced light or the reflected light we are registering. And here we have various cells that are, most of the cells, they are checking if how bright it is, but we have some color specific cells. Some are registering blue, some are registering in the red area, and some are registering in the green area. And if we look then at some of the stars, we can finally find the explanation why we cannot see something as green. So if we have a star with a surface temperature of 3000 Kelvin, so a small star, not very hot, this is not very hot for a star, then such a star like a red dwarf would typically emit most of the light in the infrared area where we will not be able to see it, but it has also something in the red, but not so much in the blue. So when our eyes look at such an object, they will be registering that it's red because there is much more red than there is blue. If we look at a blue star, it's really hot. It's over 10,000, maybe 20,000 Kelvin. This actually emits a wavelength in the ultraviolet range. So basically, we can't see all this light, but in our eyes, this would be looking blue because there is much more blue than there is red or yellow. So the blue receptors will say to the brain, or the brain will interpret this as a blue star. And then to something we know, the yellow star we are orbiting around, it's somewhere intermediate in temperature, let's say around 6,000 Kelvin. It emits in the band of the visible light, primarily not ultraviolet or infrared, even if there is ultraviolet and infrared, but you can see the main emission is in the visible spectrum. So these our eyes will see that there is some blue, there is some red, there is some yellows, there is the maximum is actually around the green, but our eyes will not interpret this as green, they will interpret this as yellow, white. And basically there is simply no temperature we can put a star on which our eyes will be able to perceive as green. So this is the explanation that our eyes, even if you have the highest emission in green, it will never be interpreted as green. And it's if you want to think philosophically and evolutionary about it, how is it funny that our eyes are tuned to where our sun has the maximum, let's say, in the visible, what our eyes can perceive is where our star is emitting most of its energy and light. And if we were living probably around the blue star, not that I think it's possible, but then our eyes probably would have been tuned further up in the ultraviolet area. And if we were living around a red star, we probably would be seeing more in infrared, and this would not have made any sense for our eyes to be sensitive in this area. So I think this concludes the video. I hope you understood, and it made some explanations why we can't see green stars. And please let me know your comments, and please press a like and subscribe to the channel, where I will be bringing you more fun facts of science, technology, energy, history explained. So with these words, we're signing out. Stay safe out there, and bye-bye.